morning, sir. Today, I'm going to discuss the evidences of plate movements. I know we already discussed some of the evidences of plate movements, but there are some additional and important information that we didn't tackle in this lesson. Evidences of plate movements. There are pieces of evidence that support Wigner's theory. First, the feet of the continents. If you look at the world map, you will notice that it somehow looks like a big jigsaw puzzle, when you can rearrange and merge the pieces as if they belong to only one big piece. The age of the continents matches the age of another, such as that South America and Africa, and Eurasia and North America. About 100 years ago, a German scientist named Alfred Wegener made the observation that continents fit together. This led him to suggest a new idea that the continents were once part of a single piece of land called Pangaea. It split apart 1 million years ago, and the continents moved to their present position. The geometrical fit of the continents now, separated by oceans, has long been discussed in relation to continental drift. This paper describes fits made by numerical methods with at least square criterion of fit for the continents around the Atlantic Ocean. The best fit is found to be at the 500 FM. The second evidence are fossils. Fossils are preserved remains of organisms, plants and animals from the past. The fossilized leaves of the Velociraptor, which were found in rocks that is millions of years old, have been found in different continents such as South Africa, Australia, India, and Antarctica. What is a fossil? Fossils are the preserved remains of plants and animals whose bodies were buried in sediments such as sand and mud, after ancient seas, lakes, and rivers. Fossils also include any preserved recent life that is typically more than 10,000 years old. These preserved remains of plants and animals show how the southern continents were once joined in the supercontinent Gondwana. Fossil remains of this ancestral mammal are found in Africa, Madagascar, India, and Antarctica. These preserved remains of plants and animals show how the southern continents were once joined in the supercontinent Gondwana. Fossil remains of this ancestral mammal are found in Africa, Madagascar, India, and Antarctica. Fossils are found across all continents in the southern hemisphere. Fossils of these freshwater reptiles are found in Africa and South America, lands now separated by a large ocean. And also, fossils of this ancestral mammal were found in Africa and South America. The third evidence is similarity of rock types. It is also noticeable that the rock formations in Africa and South America line up as they form a long mountainous range. Likewise, the age of rocks found in some coastlines, such as in Africa and in South America, were found to be similar. Ang kuan po niya, sir, ang mga bato po nga dapat hindi laha usa nga continents nagkakamayta or mayda nabibilingan. Pero nabibilingan po lahat niya dito ha usa nga continent bisan di pwede ito mahingat ka nga rock. Asya mas napapakusog ang theory and continents is usa nga big jigsaw puzzle nga nagburuglagla. The third evidence is coals. Coals are formed from organic compounds such as dead plants and animals. Looking at the current location of Antarctica, one can say that it could not sustain life. However, coal deposits were found in these regions, which means that Antarctica was once part of a region that contained life, and it was able to experience a tropical climate. The presence of coal indicates that the continent was once inhabited by many organisms. It also gives a clue that Antarctica was once located near the equator, where abundant animal and plant organisms could be found. The fourth evidence is the lights. The lights deposits of rocks debris left by glaciers. These delights of the same age were found in Africa, South America, India, and Australia. These delights suggest glaciers were once present in those countries a long time ago. This is the evidences that support plate movement theory. Henry Hess is the one suggested for continental theory. Seafloor spreading theory. Surface through the mid-ocean ridge. These materials cause the crust to move sideways, carrying with them the seafloor that moves away from the ridge and creating a crack in the crust. Evidences of seafloor spreading. First, rocks are younger at the mid-ocean ridges. The edges of the rocks becomes older as they are located farther from the ridge. Sediments are thinner at the ridge. And lastly, rocks found at the ocean floor are younger compared to rocks found along the continents. The theory of seafloor spreading was further strengthened by the discovery of magnetic reversal. Magnetic reversals happen when the North Pole transforms into the South Pole and vice versa due to the direction of the flow in the outer core, which is the main source of Earth's magnetic field. This reversal is evident among the rocks in the ocean floor. Magnetic patterns of rock in the ocean floor show that magnetic reversal happened. Therefore, when the Earth's magnetic field reverses, a new stripe with a new polarity begins. Such magnetic patterns lead to recognition of the occurrence of seafloor spreading, and they remain some of the strongest evidence for the theory of plate tectonics. Further evidence supporting the plate tectonics theory. From the pieces of evidence that were presented by Alfred Wegener to support his claim about his continental drift theory, this continental drift and seafloor spreading of Harry Hess became the foundation for the plate tectonics theory. Over the years, scientists have found additional evidence for the plate tectonics theory. In addition to the evidence provided in the continental drift theory and seafloor spreading, these are ocean drilling, mantle plumes, and hotspot, polymagnetism of ocean drilling. From 1968 up to 1983, there were several deep ocean drilling projects that were launched. The aim of these drilling projects was to know the age of the ocean floor by gathering samples. The Glover, the Glomar Challenger, a drilling ship, was built to pursue the said project, which aimed to drill thousands of meters deep. Hundreds of holes were drilled in the ocean floor, and this is being done to get samples for analysis and to find out how old the seafloor is. Mantle plumes and hotspots. In studying the chain of volcanoes along the Pacific Ocean that runs from the Hawaiian Island to the Aleutian Fringe, it was found that the age of the volcanoes increases as the distance from the big island of Hawaii increases. Encyclopedic entry vocabulary. A hotspot is an area on Earth that exists over a mantle plume. A mantle plume is an area under the rocky outer layer of Earth called the crust, where magma is hotter than surrounding magma. This is how the volcanic hotspots are formed and their relative activity as they move farther from the hotspot. And this is how ocean drilling looks like. Paleomagnetism. Earth's magnetic poles are located near their geographic poles. Using a compass, one can determine the direction of the north and the south magnetic. Paleomagnetism is the study of magnetic fields recorded in rocks, sediment, or archaeological materials. Geophysicists who specialize in paleomagnetism are called paleomagnetists. Certain magnetic minerals in rocks can record the direction and intensity of Earth's magnetic field at the time they formed. This is what polymagnetism and magnetite look